Imagine, you need an AI to optimize a massive, complex global supply chain.
Right.
You ask it to reroute dozens of cargo ships to avoid a storm, right?
Mm-hmm.
And you want it to factor in like fuel costs, port delays, cargo weights.
A logistical nightmare.
Exactly. Historically, if you asked a chatbot to do that, it would just confidently hallucinate a plausible sounding answer that would, well, absolutely bankrupt your company.
Yeah, it would just guess.
Right. But what if, instead of guessing, that AI agent could instantly hand the actual math over to a supercomputer and give you a mathematically perfect answer in seconds?
I mean, that is the dream.
It really is. And if you've been trying to keep track of where this technology is heading, you've probably noticed a massive shift. Today, we are looking at a highly specific, high-signal window of updates from NVIDIA.
Strictly between April 26 and May 2026.
Yes, exactly. This single week proves that the era of fragmented, single-task chatbots is over. We are stepping firmly into the era of unified, always-on, autonomous digital coworkers running on giga-scale infrastructure.
It's a fundamental change in how we operate.
Okay, let's unpack this. We have a ton of ground to cover, starting at the absolute core, the actual brain of the operation.
Yeah. The foundation of any autonomous system is the underlying model that powers it. I mean, you can't build a capable digital coworker if it can't perceive its environment.
Right.
And the defining research release from this specific week is a model that fundamentally changes how AI processes reality.
We're talking about the NVIDIA Nemotron 3 Nano Omni, which they detailed on the NVIDIA blog.
Yes, the Omni model.
This is an open 30 billion parameter multimodal model, and the defining feature here is unification. It natively combines text, image, video, and audio perception into a single, cohesive architecture.
Because, the problem it solves is the severe fragmentation we used to deal with.
Oh, it was awful.
Right. Historically, if you wanted an AI agent to, say, watch a live video feed from a factory floor, listen to the ambient audio for mechanical anomalies, and read the on-screen diagnostic text, you had to physically chain together 3 or 4 entirely separate, siloed models.
Which is just so inefficient.
Totally. You need an optical character recognition model for the text, a speech-to-text model for the audio, and then a language model to try and make sense of it all.
Which honestly feels like playing a massive game of telephone.
That's a perfect way to put it.
Every single time you pass data between those separate models, you lose time, you lose processing power, and you lose the broader context of what is actually happening.
It spikes your latency and drives orchestration costs completely through the roof. The Nemotron 3 Nano Omni replaces that entire fragmented perception stack.
Wow.
Because it natively fuses these modalities from the ground up, it delivers up to 9 times higher throughput than comparable Open Omni models.
9 times?
Yeah, up to 9 times. And it does this while topping 6 different industry leaderboards for complex document and audio-video reasoning.
Okay, but to really grasp how this works without burning through massive amounts of power, we have to look at the architecture.
The mixture of experts.
Right. It's an OE design, specifically a 30B A3B model. I like to think of this like a massive university.
Okay, I like that analogy.
The university itself has 30 billion parameters, which represents the total faculty across every single discipline. But when a student walks in and asks a specific question about, say, 18th century literature, the entire university doesn't wake up to answer it.
Because activating every single parameter for a simple query is just an incredible waste of computational energy.
Exactly. Only the relevant department, the specific experts representing 3 billion parameters in this case, wakes up to handle that specific prompt.
Right.
And that sparsity allows the model to deliver frontier-class reasoning really quickly. But wait, hold on, though.
Yeah.
If it's processing high-definition video, streaming audio, and text at the exact same time across a massive 256,000 token context window, wouldn't a local robot or device need a supercomputer strapped to its back just to run a single query without melting down?
You would think so, yeah.
So how is this actually practical out in the real world?
What's fascinating here is the underlying math of how this model reads data. You see, traditional self-attention transformers suffer from something called quadratic memory bottlenecks.
Okay.
Basically, as the context window gets longer, like when you feed the model a continuous long video stream, the memory required to process it explodes exponentially. It hits a wall very fast.
Right. The system just gets overwhelmed.
Exactly. But the Nemotron 3 Nano Omni uses a hybrid Mamba 2 state space model architecture.
Wait, so instead of the memory needs exploding exponentially the longer a video runs, the Mamba 2 architecture allows it to scale linearly. It just ticks up steadily.
Yes. That is the crucial breakthrough. It bypasses that exponential memory bottleneck entirely.
Oh, wow.
And when you combine that linear scaling with what NVIDIA calls efficient video sampling, or EDS, the capabilities jump dramatically. The model uses 3D temporal spatial convolutions to handle high-definition visual reasoning, native 1920 by 1080 resolution with near-zero latency.
Okay, 3D temporal spatial convolutions is a serious mouthful.
It is, yeah.
Does that simply mean the AI is looking at how pixels change over time, like tracking a mechanical arm moving across a factory floor, rather than just staring at a flat, static, disconnected series of images?
That is a perfect way to visualize it.
Sure.
It tracks the physical structure of the video and the text content coherently across time, and it does it without needing a warehouse-sized supercomputer for every single inference pass.
So we have this incredibly efficient, highly capable brain in the cloud, but, shrinking the memory footprint of the architecture is really only half the battle.
Definitely.
If you actually want to take that brain and put it inside a physical factory robot, or say a drone monitoring an oil pipeline, you hit a massive physical wall.
The local memory limits.
Exactly, the extreme memory limits of local edge devices.
Pushing intelligence from the cloud to the physical edge requires an entirely different software approach. And the updates from this week show a very deliberate strategy to make local, on-device AI a reality.
Yeah, let's look at the developer tools they released on GitHub. On the exact same day the Nemotron 3 Nano Omni launched, NVIDIA released version 0.7.0 of TensorRT-Edge-LLM.
Right, their edge inference runtime.
Exactly. It's their high-performance edge inference runtime. It brought day zero support for the new Omni model, meaning developers could use it immediately. But the really critical detail here is the introduction of an experimental ONNX conversion workflow.
This is a vital piece of the puzzle for edge deployment. When you are deploying an autonomous agent on a local device, say, a robotic arm powered by an NVIDIA Jetson module memory is your absolute tightest constraint.
Oh, for sure.
You don't have hundreds of gigabytes of VRAM sitting around like you do in a data center. You have to squeeze every single drop of efficiency out of the hardware.
It's like packing for a month-long international trip, but you're only allowed to take a single carry-on bag.
Exactly.
You have to use compression bags, roll everything perfectly, and just leave the bulky stuff behind. The new quantization workflow in this TensorRT-Edge-LLM update reduces total memory consumption by over 70%.
Which is huge.
It essentially compresses the model without stripping away its intelligence. And remarkably, it manages to do this with zero GPU consumption during the conversion phase.
Which means developers can prepare and compress these models on standard machines and then deploy them directly to highly constrained edge environments.
That's incredibly practical.
It takes advanced multimodal agents and makes them viable to run locally, completely independent of the cloud. If the Wi-Fi goes down in a manufacturing plant, the robot doesn't suddenly freeze up. It just keeps reasoning and operating.
But it's not just about perceiving the environment locally, right? It's about making highly complex decisions. That brings us back to the supply chain scenario we talked about at the very beginning of this deep dive.
Yes, the math problem.
Right. Another major developer release from this window tackles that exact math problem. NVIDIA published an open-source reference workflow on their developer blog, combining a large language model with its GPU-accelerated QOpt solver, utilizing LangChain agent skills.
The QOpt integration addresses a fundamental known flaw in how language models operate. LLMs are incredible at reasoning, summarizing, and understanding natural language, but they are notoriously terrible at strict mathematical optimization.
They really are.
They're language engines, not calculators.
Here's where it gets really interesting. We are moving from chatbots that just generate text to agents equipped with tools to do rigorous, flawless math.
Right.
It's like me doing my taxes. I know what needs to be done in plain English. I know all the rules, but I absolutely need to hand the actual math over to a calculator before I submit it, or, I'm going to get audited.
That is the exact mechanism at play here. If you ask a standard LLM to optimize a global shipping route, considering hundreds of variables, fuel costs, port delays, vehicle capacities, driver shift limits, it will just try to predict the next most likely word and give you a mathematically incorrect answer.
It'll just sound really confident while being totally wrong.
Exactly. But with this QOpt agent skills workflow, the LLM doesn't try to do the math itself.
It functions entirely as a translator and a project manager.
Yes. It takes your natural language query, formulates it into a strict mathematical routing problem, and hands it off to the QOpt GPU solver.
And the solver handles the heavy lifting.
The solver crunches the actual numbers across millions of possibilities in a matter of seconds. It then hands the mathematically perfect optimization back to the LLM to present to you. It's a production-ready blueprint for translating human intent into rigorous, real-time supply chain execution.
It's the brain seamlessly handing the heavy lifting over to the calculator. I love that. So we've covered the multimodal models, the edge runtimes that shrink them, and the routing APIs that let them do math. But let's zoom out a bit to the corporate level.
Okay.
When a massive global corporation wants to deploy thousands of these agentic systems at scale, where does this all physically run?
Well, you're asking about the physical infrastructure, and that brings us to the concept of the AI factory. The intelligence has to live somewhere, and standard data centers are just not equipped to handle always-on agentic workflows.
Yeah, and we saw a massive technical release aimed squarely at this problem. On their technical blog, NVIDIA published a detailed, validated full-stack design blueprint called the NVIDIA Enterprise Reference Architectures.
Right.
This is specifically for building enterprise AI factories utilizing their latest Blackwell GPUs, Bluefield DPUs, and Spectrum-X Ethernet networking.
This is a critical transition indicator for the industry. NVIDIA is no longer just selling individual chips or networking cards. They are selling the entire prescriptive AI factory blueprint.
Because you can't just buy 10,000 Blackwell GPUs, plug them into a standard corporate server rack, and expect them to work.
No, absolutely not.
The networking bandwidth required to keep them fed with data, the liquid cooling logistics, the software orchestration to prevent bottlenecks, it's incredibly complex. It's like trying to build a nuclear reactor from scratch using just a pile of parts.
Exactly. This reference architecture codifies the exact design needed to make it work. It gives systems integrators, companies like Dell and Cisco, a standardized, validated hardware and software substrate.
It just takes the guesswork out.
It removes the guesswork entirely. If an enterprise wants to move from running a few agentic AI pilot programs to full-scale, company-wide production, this blueprint tells them exactly how to build the infrastructure to support it.
But building these massive AI factories to power highly capable, always-on agents brings up a terrifying concern.
Security.
Yeah. If you have an AI running 247, making autonomous decisions, reading internal company data, and executing code on the factory floor, what happens when it gets hacked? A security flaw isn't just a glitch in this scenario, it's a catastrophic vulnerability.
Security is the absolute bottleneck for enterprise adoption of autonomous agents. And the events of this week highlight both the reactive challenges and the proactive solutions in securing these systems.
Let's look at the reactive side first. The Associated Press reported on a security bulletin disclosing critical vulnerabilities in the NVIDIA Flare SDK, specifically CVE 2026-24178 in the NVFlare dashboard.
Yeah, this was a severe flaw. It allowed an unauthenticated attacker to bypass authentication entirely using a user-controlled key.
To put that in perspective for you, a bypass like this means an outsider could theoretically hijack an AI agent that is actively managing a physical network.
Right.
Or tamper with the training data of a model just by tricking the system into thinking they have the master key.
It's a huge risk.
The consequences are massive data tampering, privilege escalation, and denial of service. Organizations running this had to urgently upgrade to NVFlare version 2.7.2 to secure their networks. It's a really stark reminder of the stakes involved when these systems touch reality.
If we connect this to the bigger picture, you can see why NVIDIA is simultaneously pushing so hard on proactive governance and sandboxing. Reactive patches are necessary, but they just aren't enough when dealing with autonomous agents that have the power to execute physical actions.
Which perfectly explains the news from the Nemotron Labs blog. NVIDIA detailed its collaboration to harden a wildly popular open-source project called the OpenClaw Agent Runtime.
Right, they released NemoClaw.
Yeah, they released a secure, enterprise-ready version called NemoClaw.
OpenClaw has massive traction with developers because it's flexible, but enterprise IT departments are absolutely terrified to let community-built autonomous agents run loose on their internal corporate networks.
I don't blame them.
Right. NemoClaw is a secure reference deployment designed to solve that trust issue. It takes the OpenClaw runtime and wraps it in an OpenShell isolated sandbox, paired with the Nemotron open models.
It's essentially a quarantine zone for the AI.
That is exactly its function. It operationalizes model isolation and data privacy. It ensures that even if an always-on local agent is compromised by a hacker, or if the model itself hallucinates a destructive command, it is physically trapped within an enterprise-grade sandbox.
So it's contained.
Exactly. It cannot reach out and delete a corporate database or shut down an assembly line. This quarantine zone gives companies the confidence to actually deploy these persistent digital coworkers without risking their broader internal networks.
Okay, so the foundation is well and truly laid. We have the unified brain capable of seeing and hearing. We have the runtimes to shrink it down to a carry-on size. We have the AI factories to host it at scale, and the sandboxes to keep it quarantined and secure. So the ultimate question is, what are the tangible business results? Is this actually changing how industries operate today, or is it still just theoretical?
We are officially moving past the hype phase and into measurable, quantified return on investment. And this transition is most visible in industries dealing with heavy, expensive physical reality, like manufacturing.
Right. The NVIDIA blog published a fascinating piece titled Into the Omniverse, Manufacturing's Simulation First Era. They showcased real-world deployments, highlighting ABB Robotics.
Oh, this was really cool.
ABB integrated NVIDIA's Omniverse libraries into their Robot Studio hyperreality platform.
This is the realization of the digital twin concept at an industrial scale. Before a company builds a physical robotics assembly line, which costs millions of dollars and takes months to calibrate, they simulate it perfectly in a virtual environment.
An environment that obeys the exact laws of physics, gravity, and friction. And the ROI metric they shared is the undeniable proof that this works. ABB Robotics achieved 99% simulation to reality accuracy.
Think about how that changes a roboticist's day-to-day job. If your simulation is 99% accurate to the real world, you don't need to build iterative physical prototype.
You save so much time.
You don't have to weld metal, test it, realize it clashes, and scrap it. You train the AI agents and test the robotic firmware entirely in the digital world. You run 1,000 variations virtually, knowing it will work exactly the same way when you finally deploy it on the physical factory floor.
It completely compresses the timeline. The report noted a 50% reduction in product introduction cycles.
That is massive.
That is a concrete, quantified ROI. They aren't just selling a futuristic vision anymore. They are selling a software pipeline that cuts a massive manufacturer's time to market completely in half.
And naturally, all of this software adoption, all of these infrastructure blueprints and these edge deployments inevitably flow back to the financial foundation of the company driving the shift.
Which brings us to the final piece of news for this specific window. NVIDIA Investor Relations announced they will host their Q1 FY2027 earnings conference call on May 20, 2026.
Crucially, this covers the financial quarter that ended strictly on April 26, 2026.
Right. While an earnings call announcement is, standard corporate procedure, the context here is critical for the broader economy. This establishes the official date for the next major financial disclosure for the entire AI industry.
The entire market will be watching this call to see if the technological hype matches the balance sheet.
Exactly.
It'll reveal the hard data center revenue trends. It'll show the tangible progress of that Blackwell architecture ramp-up we discussed with the AI factories. And it will provide concrete metrics on hyperscaler spending. We'll see if the massive infrastructure build-out is translating directly into forecasted revenues.
It acts as the ultimate reality check for the pace of this technological shift. It proves whether enterprises are actually buying the blueprint or just looking at it.
Spot on.
So, what does this all mean? Let's take a step back and look at the whole picture. In just one single week of updates, we tracked the entire life cycle of the new AI paradigm. We saw the release of a unified brain in the Nemotron 3 Nano Omni, capable of perceiving text, video, and audio simultaneously without melting a supercomputer.
Right.
We saw the software tools to shrink that brain and run it locally on the edge with TensorRT-Edge-LLM. We explored the secure NemoClaw sandbox designed to keep these agents quarantined and safe from hackers. And finally, we looked at the physical AI factories and manufacturing simulations where this intelligence will ultimately live and generate massive ROI.
This raises an important question for you to consider. We are watching the underlying technology mature at breakneck speed.
We really are.
If AI agents can now seamlessly perceive their environment in real time, reason across text and video simultaneously without massive latency, execute complex math via external solvers, and operate securely within a factory setting, when does the line between a mere software tool and an autonomous digital coworker permanently blur for your own industry?
It's a profound thought to end on. We started this deep dive talking about a massive shift away from fragmented single-modality AI models. What we are seeing now is the connective tissue forming. The pieces are unifying. The agents are becoming persistent, highly capable, and increasingly autonomous.
It's happening faster than anyone predicted.
Thank you for joining us for this deep dive into the architecture of tomorrow. Stay curious.